Welcome students to our class today. We are still learning on dimension analysis, and today we're going to do one method that is called the pi theorem. So Buckingham's pi theorem, and this theorem states that if there are n variables in a problem and these variables contain m primary dimensions, the equation relating to the variables will contain n minus m dimensionless groups or pi groups. The final equation would now be obtained as pi1 a function of, so we call it a phi, pi1, pi2, and pi3, and so forth, to pi n minus m to give you the number of the dimensionless groups here, such that if you add maybe if your n minus m was 4, for example, or 3 in my case, you'll have the pi1 being a function of pi2, pi3, and pi4, and so forth and so forth. So you'd be given maybe an equation and you are supposed to determine the number of pi terms, which has been a challenge to most of the students, but today we are going to simplify it for us to be able to see how we're going to meet that concern. Now, how to determine the pi terms given an equation. So number one, you first of all list all the variables in a problem. List all the variables in a problem. Now, let's see our example that we have as we go down. In my problem, I have P for the pressure is equal to rho LV squared and a function of mu over density LV, like this, if this is your question. So number one, what you need to consider is, first of all, identify all the variables in that problem. The variables simply are, for this case, you'll have pressure, you'll have density, you'll have the length, the velocity, and mu. So we have five of them. So we have 5 variables here. Procedure number 2 is that you express the variables in terms of their basic dimensions. So in our previous video, I was able to show us the dimensions. For example, density, mass per unit volume, this is how you write it. L for the length, this is the head, and it's in meters, and so forth and so forth. So head is simply L, sorry, so this is L. So express all the variables in terms of their basic dimensions. So in my case, in my example, I have the dimensions listed here. These are the basic dimensions of each and every one of them. Number 3, you determine the pi terms. The pi terms, remember we said it's n minus m, and n is simply from our procedure number 1. We add 5 of them. So 5 minus m, which is the primary dimensions. So you look at the problem and identify how many primary dimensions are there. So if you have a challenge still on identifying the primary dimensions, please get back to our video and you'll be able to see how to identify the primary dimensions. Number 4, select the repeating variables, giving priority to the most appearing variable. Now, in number 4, let's still have a look at our example here. Remember we're saying that you select the repeating variables. Repeating variables will give you the right hand side of your problem. So we have P, the density, and all this. So we're picking our repeating variables from here. So for example, here we have L and it's squared, V and it's squared. We also have L and V here, and the density as well. So what you identify here, first of all, get the geometric one, get the geometric variable, which is picked from LT. Number 2, consider also the dynamic variable, which is being repeated the most, which is in terms of their dimension, and kinematic variable. So get to identify the 3 from your problem. So in my case, I'm picking the rho, the L, and mu. So L for the length, this is density, mass, which is the M and L, and mu containing the M, L, and T, all of them. So that is your procedure number 4. Number 5, you write now the expressions in terms of pi, a function of pi2, pi3, to the number of the dimensions that you have. In my case, we add 5 of them. We add 5 variables. We add 5 variables. 5 variables, and we also have 3 primary dimensions. So 5, this is our n. So 5 minus 3 would give us 2 pi groups. So are we going to write our dimensions in terms of pi 1, pi 2, and pi 3 is pi 1 is now given by a function of pi 2. There are 2 pi groups, just like that. So we'll have pi 1 and pi 2. Let's say, for example, maybe you add your n as 6 and 3 primary dimensions. This gives us 3 pi terms or pi groups. So how we're going to write this is pi 1 is given by a function of pi 2, pi 3, like that. So these are 3 pi groups. So we're going to do one example and see how we are going to put this in an example to help us in solving dimensional problem using Buckingham's pi theorem. So an example, we're going to do part B of that question. Show by dimension analysis, Buckingham's pi theorem method. We have the question and we are told that our R is the wave resistance. So we're going to rewrite our equation as it is. So this is the squared. So like we said in our procedure number 1 is that we need to identify first of all the variables that are present here. So we have R as the first variable, we have the density, we have L, velocity, mu. So I'm not going to rewrite this because I already have it here. V, I already have it here. We have the L, which is here and here. I'm not going to rewrite them. And that would be our last variable. So we have 1, 2, 3, 4, 5, and 6. So this is like our n is 6 variables. Now number 2, let's now write the dimensions of each and every variable. So R is remember it's the wave. We are given that R is the wave resistance and it's given by M, L, and T -2. The density is M, L, -3. So L will still remain as our L. We have velocity, which is distance per unit time. We have the mu. This is M, L -1, T -1. I'm remaining with density, not density but acceleration due gravity, which is L, T -2. So these are the dimensions. Now let's identify the repeating variables so we can be able to know how many pi groups are we going to have. So the repeating variables here, if you still recall that we said you're going to use it, identify the aspect of dimension, one in dimension, and considering the most repeating, get the dynamic quantity and the geometric quantity. So I'll have the first repeating variable would now be our rho, L, and finally V. So this is for the kinematic factor, for the geometric, and the density with an M. So these are our repeating variables. We have 3 of them. So we're going to have the remaining, that is the R, which other one? The mu, and acceleration due to gravity. So we're going to pick this adding each and every one of them as you go down. Now, number 3, let's identify the pi terms. How many pi terms are we going to have? So, pi terms, remember we said it's n minus m. So, in all these dimensions, you can see that we have the m, we have the l, and we have the t. So, we add 6 variables minus 3 primary dimensions, which are m, l, and t. So, this is giving us 3 pi terms. 3 pi terms. Now, let's write the pi terms. So, the term number 1, or pi number 1, is now the row LV with, please consider this, row LV with R. That is number 1. Pi term number 2 is row LV with mu. And lastly, pi number 3 are the repeating variables with acceleration due gravity, such that we will have 3 equations here. And from the 3 equations, we will need to combine them to take us to our previous equation, or the equation that was required up there. Now, let's now begin to do it in Buckingham's method. So in Buckingham's method, this is how we do it. We know the primary dimensions, m, l, and t. So should be equal to, please indicate this as 0, 0, 0. This is the simplest way. Then bring in the repeating variables. Let's begin with this. Our density, the dimension for the density was m, l, negative 3. Put a dot, a multiplication sign. So our next is L, and our L was simply like that. Put another dot, bring in the V, or velocity. We add L, t negative 1. Remember we're saying width, so the next one would be the dimensions of R, the wave resistance. So M, L, t negative 2. Now, please. So the MLT were all for the row, and we add our row here as ML power of negative 3. L is for this L as a repeating, which is here. LT negative 1, all this for V, and the V we add the dimensions as LT negative 1. Now the entire is R. Remember from the first pi term R, and what was our R? It is MLT negative 2. So we have all the variables here given their dimensions. Now number two, we're going to put, remember I'm putting the powers 0, 0, 0 here. For the, in my right hand side, now indicate this, all of them as A. So this is to power A, multiplication, the second variable, power B, the third variable, power C, and this power C. So for the last variable here, which we add them as additional, please don't put any power in terms of letters. We're going to use it like it is. Now, let's now identify how many M. So we're going to have, let me begin with M, the variables of M. So M is 0 from the powers. Now, 0 is equal to, this is M power A. So this is A. Do we have another M? It's here. This is like raised to 1, and it's positive. So A plus 1. Now, for L is raised to 0. So 0 is equal to, we have the first L here, which is negative 3A. Pick the powers alone. So negative 3A. And we have another one, which is plus B. This is another L, and plus C. Remember, this is positive because we don't have any negative indicated here. Just like we did for M, this is L raised to 1. So plus 1. So we finished all with the powers of LO. Next is T. T is 0 is equal to, how many T are here? We have, this was T raised to 1, and we're putting negative C. So I can simply write it as negative C minus, this is power of negative 2. So I hope that you have got that correctly. Now we have 3 unknown letters here, the A, B, and C. So let's identify each and every one of them. So from 0 is equals to A minus 1, we can have this. Remember, 0 is equal to A minus 1, A plus 1, sorry. So to have our A alone, this is like taking 1 to the other side. So we'll have our A being equal to negative 1. For B, we will have, this is known, this is unknown, and this is also unknown. So we can simply leave this a bit and then deal with C so that we can come back and get C and A as our 2 knowns. So this would now be 0 is equal to negative C minus 2. So it's easy for us to take C on the other side to remove this negative. So this is C being equal to negative 2. So that's our value of C. Let's get back now and replace A and C so that we can have B as the only remaining unknown here. So from here, let me do it from this side, as is also possible. So we have 0 being equal to negative 3, A. So what was the value of A? It's negative 1. So negative 1 plus B, which we are going to find, plus C, which is negative 2, putting it in bracket, plus 1. So if we open this bracket, we always know from mathematics that 2 minuses will simply be positive. So this is 3 plus B minus 2 plus 1. So this is still 0. So this would give us, this is 3 plus 1, 4 minus 2 to give us 2 plus B. So it's simply, it would be simple for us to take 2 on the other end and have the B being positive. So the value of B here would now be negative 2. Now I have the 3 terms. I have A being equal to negative 1, C being equal to negative 2, and our B being equal to negative 3. Now, let me take us back a bit. So there is something I forgot here. So we were doing the pi one. So this is rho LV with R. So if you realize that all these were for the row. So this was raised to A, L was raised to B, the entire, and this to C. So we didn't have any value being raised for the R. So we have the A, B, and C for density, L, V, and R. So we're going to replace these values. Remember, we have the values like we did, the A, the B, and C. We're going to replace them here and see the powers. So this was our pi 1. Now, we are replacing the values A, B, and C. So our A was negative 1. So pi 1 is now rho raised to negative 1. L raised to B, which is negative 2 here. So L raised to negative 2, and then V raised to C, and our value of C was negative 2. So negative 2 with R. So you can see that this one are raised to negative. So we can simply rewrite this as our pi 1 is now given as R over rho L squared V squared. That is our first pi term. R rho L squared V squared in division. So you're going now to our pi number 2, pi 2, which we have rho LV with mu. Rho LV with mu. So we have rho LV with mu. So we're going to raise this to A, B, and C. Their powers to A, B, and C. So let's begin by giving our primary dimensions. MLT is now equal to, we know our rho from here, ML negative 3. ML negative 3. So I'm going to write ML negative 3 raised to A, that is, put a point, then L is L, it's like we had initially. Next one is V, velocity. This is our V dimension, so L T negative 1 with mu, which is M L negative 1 T negative 1. Now bring in the powers in terms of ABC like you had indicated here. So this is it for L and for V. So this is raised to A, B, and C, and also C here. So I said for this we put them as 0, 0, 0. Now begin to solve for M, L, and T. So this is 0, 0, 0. So for M, how many powers? For M we have M raised to A. So we have, remember we're speaking from the powers alone. So A, another M is here. So this is like raised to 1 and positive. So plus 1. For L we have 0 is equal to negative 3A plus B plus C and minus 1. Lastly is T, so it is 0 raised to, we don't have a T here up to this point, so this is negative C, and another one here is negative 1. Now our values of A, B, C, so for A, remember it was 0 is equal to A plus 1, so we can simply take 1 to the other side and have our A being equal to negative 1. So these are two unknowns like we did initially. It will be easier for us to identify the value of C first. So take C to the other side, and this gives our value of C as C equal to negative 1. Because this is negative, if we pick it to the other side, it becomes positive. So C is equal to negative 1. B is negative 3A, so it is 0 equal to negative 3A. What is our A? Negative 1. Plus B, which you're looking for, plus C, the entire C is negative 1, minus 1. So this is positive, so this would be 3 plus B minus 1 minus 1. So these are negative 2, and this is positive. This gives me 1 plus B equal to 0. So this is already positive. Take B, 1 to the other side. You have your value of B as negative 1. So let us now replace our values. You already have our value of A as negative 1, C as negative 1, and B as negative 1. And we had written it in form of rho LV raised to ABC with mu. So wherever we have an A, we put in negative 1. Wherever we have B, we put negative 1. And C, we're replacing it with its value as negative 1. So this is written as rho raised to A, which is negative 1, L raised to B, and our value is negative 1, V raised to C, which is negative 1, with mu. So our pi 2 is now written as mu over raised to 1 L and V. So this is our second pi term. So let's now go to our pi 3. Our pi 3 was rho L V with G. So our pi 3 is rho L V with G, acceleration that is. So begin by putting the powers. So we have this as A, B, and C, our G. So bring in the dimensions. So M, L, T. For the density, we have it as, we can pick it from what we had initially because it's still the same. So ML negative 3. Next is L The other one is now v, which is lt negative 1 with, so the g, I think we need to have a look at our g. So our g was initially lt negative 2, lt negative 2. So lt negative 2. So remember the powers. So let's indicate this is A, all for the density, B, C, and we said that we are not adding powers in the last dimension. So this raised to 0, 0, and 0. Now let's identify all powers for M, for L, and T. So M 0 is equal to, we have A, and we don't have any other value for M, so that one is done. So L is power 0, another L is here, so negative 3A plus B plus C plus 1 here. Last is T powers, so we don't have a T here, up to here for velocity, so negative C, and this other one minus 2. So identify the values. So simply this 0 is equal to A, it's like being told A is equal to 0. So our value of A is simply 0. For C, on the other side, so C is equal to negative 2. Now we can compute for B here. So negative 3, A is 0, plus B, plus C, which is negative 2, negative 2 plus 1. So this one is done. We'll have B minus 2 plus 1 equal to 0. And so our value of B would simply be negative 2 plus 1, that is minus 1. So take it to the other end. So B is equal to positive 1. So this is equal to 1. Now let's replace our values. We have our A as 0, C as negative 2, and our B as L, not L, sorry, but B is equals to 1. It's positive, remember. So let's replace it here. So we have our row raised to A is 0, that means we will not have row appearing anywhere. We have L raised to B, which is 1, positive, and C, which is V raised to C, so V raised to negative 2 with G. So our pi 3 can now be written as, these are positive, so you'll avoid 0 because it's simply, that means this variable will not appear in our equation. So we'll have this as positive, will be on the numerator, and G over V squared. So this is our pi term number 3. Now let's bring in all our pi terms. We had our pi 1 as R over rho L squared V squared. Our pi 2 as mu rho L V, and our pi 3 as LG V squared. So remember we said we are putting our formula now as pi 1 is a function of pi 2, pi 3, all the way to pi n minus m in this manner. So what was our pi 1? So it's R over L squared V squared. Function of our pi 2 is here, mu LV and LG V squared. This is our pi 3 squared is here. So that is our equation. Now we can simply have this on this other side, so we can simply multiply because we have an equal sign here. So multiply it on the sides and you have our function, the wave resistance now being equal to, the wave resistance being equal to rho L squared V squared, function of mu, put this in bracket, rho LV, put a comma, LG V squared. So we are done with our question that required us to show by dimensional analysis Buckingham's pi theorem that wave resistance is given by this formula. So that is it. It's the simplest way and very interesting, also when you have understood the dimensions of each and every variable. Thank you so much for watching. I hope this video was helpful. Keep on subscribing and supporting us in this channel. Thank you.